This is one of the most popular 2D matrix questions in technical interviews. So we are given a 2D matrix that contains 3 possible values. The first value in the matrix is -1, which represents a wall or an obstacle. The second value is zeros, which represents a gate. And lastly, we have infinity, which represents empty space, and we will use the maximal integer value to represent infinity. Our task is to fill each of the empty space with the distance to the nearest gate, and if we can't reach a gate, we will place the maximal integer value at the cell. Let's say we're given this 2D matrix, we can fill the cells with the following distances to reach the nearest gates. Let's first go over the brute force approach. For each of the cells inside the matrix, we can perform a breadth first search to find the nearest gates. Now let's look for a more optimized approach. What we can do instead is start breadth first search from the gates. Every single time we find a smaller distance, we will update the cells. Let's go over the code, create a 2D matrix to allow us to traverse in the 4 directions, implement the function walls and gates, taking the input matrix, keep track of the number of rows and columns, retrieve all of the gates. While the queue is not empty, pull a cell, retrieve the row and column, iterate through the 4 directions, calculate the new row and the new column. If the new cell is out of bound or contains a wall or contains a smaller distance, continue to next cell, update the distance at the cell, add the cell to our queue, implement the function getGates, create our queue, iterate through the cells. If the current cell is a gate, add the cell to our queue, return the queue.